I decided just to make one video, so just move to the correct slide. So this first one we'll do is the elevator lab. Uh, so in the elevator lab, we had a human standing in an elevator on a scale. So there's a scale there. And so the first thing we did was we figured out the weight of this person. So let's just say this individual weighs, this individual weighs 500 newtons. Okay? So the next thing we did was we got a reading on the scale. So the force that the scale showed, let's say, was 400 newtons. Alright. And so the question was, what is the acceleration of the elevator? So the formula we're using right now is sum of the forces equals mass times acceleration. Alright? So the first thing you got to do is just free body diagram. So if you draw a free body diagram on the scale, you'll notice that you have the force of gravity, or the weight of our person, and you will have the normal force on the scale, the force the scale is showing. And those two things are acting against each other. So those are our two forces, so the sum of the forces would be the normal force plus the force of gravity, and that'll be equal to mass times acceleration. Okay, so let's move over one, plug in our numbers. So we've got normal force is 400, and the force of gravity, or the weight, is 500, and it's negative because it's going down, and that should equal mass times acceleration. But we don't have the mass, so we have to figure out what the mass is of this object. Well, if they weigh 500 newtons, if they weigh 500 newtons, let's see if I can fill that back in real quick. Yeah, so they weigh 500 newtons. So if that's the case, then remember force of gravity, or weight, is equal to mass times 10. So we can just divide 500 by 10 and get the mass is equal to 50 kilograms. So then we come over here, 50, and we get negative 100 equals 50A, which would be negative 2 meters per second squared. And that would be the answer. And so if it's going down, it would be negative. If it's going up, it'll be positive. If this number, the force the scale shows, is bigger than the weight, it will go up, and if it's smaller, it will go down. All right, so that's the that problem. So the glider problem was our next one, and on that one, we collected acceleration. Let's just say in this case it is 200 meters per second, or sorry, let's say it's 2 meters per second squared. We collected the mass on the hanger, which was, let's say in this case, 120 grams, or 0.12 kilograms. And we collected the mass that we had added, the total mass we had added. And let's just say in this case it is 150 grams, or 0.15 kilograms. Okay, so what we had to do was recognize that if we had a system that looked like this, with the hanger here, this in blue is the hanger. So if that was the hanger, and in red will be the scale. So this guy had the force of gravity pulling down and the tension up, and this guy just had tension acting on him. Okay, so notice that the tension should be roughly the force of gravity, and then that would mean that the thing pulling this one this way would be the tension, and so it would be the force of gravity acting on it, right? The force of gravity is on the mass hanger. So what we did was we found the weight, or the force of gravity, of the mass hanger. So the force of gravity on the mass hanger in this case would be 1.2 newtons, and we said the sum of the forces has to equal mass times acceleration. So really the only thing acting on this is this force of gravity, and we can think of it acting on this whole system here. Okay, we can think of it acting on this whole system, and so the force of gravity equals the mass of the glider plus the mass we added. Let's add, there we go, mass we added times the acceleration. So in our case, the formula kind of looks like this. So if we look at it, we would get 1.2 newtons equals the mass of the glider plus the mass we added times the acceleration, which was 2 meters per second. So we would get, if we found this, we would get 1.2 divided by 2 equals mass of the glider plus 0.15. So if we do 1.2 divided by 2, we get 0.6 equals mass of the glider plus 0.15. And we would subtract 0.15, and we would get this. In this case, the mass of the glider would be 0.45 kilograms equals the mass of the glider. All right, so that's how you do the glider lab. All right, the last one was the one we did today, and we'll call this the friction lab. Okay, so on this lab, what we had was the mass of the tennis ball, 0.06 kilograms, a distance you pushed it, we'll call it 2 meters, and a time that it took to push. So it doesn't really matter, but we'll call it 0.5 seconds. All right, and let's make it a little bit different so it's not the same exact thing. Let's make this a little bit bigger. All right, let's say that you pushed a bowling ball. All right, and then that it was 1 kilogram to make math easy. Some kind of 1 kilogram ball that you pushed. Okay, so you're pushing this ball across, and it has some initial velocity. Okay, and the force on this, if we're drawing a free body diagram, you don't put velocities on there. But what you do know is that there is if it's going that way, there must be a friction force acting on it. And that's really the only force. The free body diagram also has the force of gravity and the normal force, but they don't really matter because they cancel each other out. So we've got this friction force that we're looking for. So the sum of the forces will be equal to the friction force, and that will be equal to mass times acceleration. So our goal on this problem was to find the force of friction, the friction that the grass had on the ball. Now, if you notice, we can do this if we have acceleration. So we know friction then will be equal to 1 times something, but we don't know acceleration. So we have to find acceleration, but all we have is x and t. So if you look at the x equals formula, you'll notice that it's 1/2 at squared plus vit, or v naught t, which is fine except for the fact that we don't have v naught. We don't know what this number is right here. So we can't really use any of the formulas except for x over t equals v plus v naught over 2. Now this won't give you acceleration, but it will allow you to solve for v naught because the final velocity should be 0. So if we do this, 2 divided by 0.5 equals v naught over 2, and we would get 4 equals v naught over 2, and then we would get 8 meters per second equals v naught. All right, now I have the v naught, so we can find the acceleration. Acceleration is v minus v naught over t, and so we would get that it is equal to 0 minus 8 over 0.5, or the acceleration in this case would be a astounding 16 meters per second squared. Okay, and so I can come over here and plug this in, put in a 16 here, and then multiply that together, and we get the friction force is equal to 16 newtons. Okay, so those are your 3 labs. All right, I hope they help. If you have any questions, please come in and see me in the morning.